All right, ladies and gentlemen, we are going to get diving into chapter 3.2, which is proving lines are parallel. If you take a look at our goals for today, we have use theorems to prove that two lines are parallel, and goal number 2 is use algebra to find the measures of angles needed so that the lines are parallel. So the first thing is we got a few postulates, just some things that we need to make sure we talk about. First one says the parallel postulate. It says through a point, not on a line, there is one and only one line that is parallel to the given line. So as you take a look, here's a point, here's a line, and there's a lot of lines that you can draw through that point, but there's only one that is parallel. And that would be that one right there, the best of my ability. So again, two lines that never intersect, that is parallel. Just a reminder, the symbol for parallel is two L's, kind of look like two lines that don't intersect. The next postulate is the perpendicular postulate. It says through a point, not on a line, there's one and only one line that is perpendicular to the given line. So again, here's the line, here's a point not on that line. And again, there's lots and lots of different lines that I could draw, but there's only one line that when I draw it is perpendicular. Remember, perpendicular is two lines that intersect and create a 90-degree angle. And remember that the symbol for perpendicular is the upside down T. All right. So a couple postulates that you should know. All right. Next, we have the two lines perpendicular to a third line theorem. It says in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So for example, if M is perpendicular to T and N is perpendicular to T, then those two have to be parallel. And that's just one of the rules. All right, next on the second page, we have a few new theorems, and we kind of talked about these yesterday. So are they new? Not so much, but we talked about them. So here we go. The alternate interior angles theorem says if two lines and a transversal line going through it form alternate interior angles and those are congruent, then the two lines are parallel. So here we go. If you remember alternate interior angles, those make the Z. And if I take a look, alternate means on different sides of the transversal. Interior, remember, this is the exterior on the outside. These angles are on the exterior. And then these are the interior of the parallel lines. If I trace out a Z here, we would say angle 3 and angle 6 would be congruent if those lines are parallel, and vice versa. If angle 3 and angle 6 are congruent, then A and B must be parallel. And again, here's A and here's B, if you will. The other angles is like a backwards Z. That'd be angle 5 and angle 4. So if angle 4 and angle 5 happen to be congruent, then we also have two lines that are parallel, A and B. All right, next is our alternate exterior angles theorem. It says if two lines and a transversal form alternate exterior angles that are congruent, then the two lines are parallel. So again, reminder, those are our two V's. All right, again, reminder, this is exterior, this is interior, this is exterior. So again, alternate means they're on the different sides of your transversal, and they're on the exterior. So if you look and trace out, this would be like angle 1 is on the left, and then angle 2, or excuse me, angle 8 is on the right-hand side. So we would say angle 1 and 8, look at, they're both obtuse, right? So angle 1, if that's congruent to angle 8, then A and B are parallel. The ones on the other sides are also alternate exterior angles. So we would say angle 2, if that's congruent to angle 7, look at, they're both acute. If those are congruent, then A and B would be parallel. The last one on this page is corresponding angles theorem. This is the one that makes an F, if you will. It says if two lines and a transversal form corresponding angles, and those are congruent, then those two lines must be parallel. So again, as we take a look, this is A, this is B. And corresponding, that word means in the English dictionary that they are matched up. So corresponding is in the same location. So think of sides of the street, and like this guy right here is the upper left-hand side of the group of four. And then over here, this group of four angles, this is the upper left-hand side. So if I trace those out, you can see the F there. All right, so we would say if angle 1 is congruent to angle 5, then we have parallel lines. And then we can go around and there's 4 sets of corresponding angles. I could go through and say, okay, upper right, look at the upper right here. The upper right over here makes a V, or excuse me, an F. We would say if angle 2 is congruent to angle 6, then we would have A and B parallel. And then so on and so forth. If I look at bottom left over here in this group of 4, matches up with the bottom left, with angle 3 is congruent to angle 7, then those guys would be parallel. And then last but not least, in this group of 4, this is the bottom right, and this is the bottom right. Again, if I trace this out, don't you see the F here? Okay, those are what we call corresponding angles. If angle 4 is congruent to angle 8, then A and B must be parallel. Last theorem for today is same side interior. Same side interior or exterior angles theorem. I always say this makes the C. All right, when I trace it out, again, reminder, this is exterior angles. Let me rewrite that. Exterior. This is interior angles on the inside of these parallel lines, and these are exterior. This is A, and this is B again. Says here, if two lines in a transversal form in same side interior or exterior angles are supplementary, means they add to 180 degrees, then our lines are parallel. Okay. So as I take a look, same side interior, all right, makes a C. If these two angles are supplementary, angle 4 and angle 6 add up to 180, then A and B must be parallel. The angles on the other side also make a C. Those are same side of the transversal, and they're on the interior. We would say if angle 3 and angle 5 add up to 180, then those guys are parallel. All right, so some examples you guys might see in my math lab for tonight. That might give you a group of lines here. We have line L and M kind of look parallel. We've got A and B. And it says, answer the following questions using the figure below. It says, which lines are parallel if angle 1 and angle 7 are congruent? So here's angle 1, and here's angle 7. You see what letter that makes? That makes a Z. All right, and if you guys remember, going back to the second page, those are alternate interior angles, congruent. And if I have alternate interior angles, just trace this out, highlight this guy. This is the transversal, and A and B must be parallel there. So if I trace out the Z now, I can see which ones are parallel. This one and this one. Right? If I take a look at the next one, we'll do angle 5 and 8. Angle 5 and 8. Here's angle 5, I'll highlight in yellow. And then here's angle 8, I'll highlight in yellow. Okay. Well, if I look, In this group of four angles, this is bottom right, and of these four angles, this is bottom right. If I trace this guy out, it makes the letter F. And now I can see I have corresponding angles as it makes an F. And those angles are congruent. Well, if I look, this is the transversal, and these are the two lines that are going in the same direction. So we would say L has got to be parallel to M. All right, on the third page, we've got example 2. It says, what is the value of x that would make the lines parallel? Set up an appropriate equation and solve. So the first thing I like to do is I like to trace out my angles. Trace them out and then connect and find out what letter I've got. And again, I've got that letter Z when I trace it out. So if I go back to my theorems, those are alternate interior angles congruent. If I have alternate interior angles congruent, if 2x minus 5 is equal, congruent, to 95, then those lines L and M must be equal. So again, when we're solving, I set those equal. Again, what I do on one side of the equation, I must do on the other. So go ahead and add the 5 over so those cancel. I get 2x equals a hundo. And then my last step, 2 times x, the opposite of times is divide. These guys cancel, and now we get 50. So if x is equal to 50, then I'll have those two lines L and M parallel to each other. The other scenario you might see is when I trace out, for example, 2b, I trace out this angle, and I trace out this angle, it makes the letter C. It makes a C, kind of a backward C. So again, if you remember, that is same side interior angles. Well, same side interior have to be supplementary. This is an obtuse angle, that's acute. There's no way those are equal. So these are supplementary. Okay, which means when I add these two angles together, 2x plus 9, and I add 111, that should be equal to 180 degrees. That's what supplementary means. Right? When the numbers are on the same side, we combine our like terms. So remember, 9 plus 111, I should get 2x plus 120. And I'm running a room, so I'm going to write up here. I'm going to go ahead and subtract the 120 over. Again, whatever I do on one side, I got to do to the other. 180 minus 120, that gives me 60. And now divide by 2. And I should get x is 30. So if x is 30, that means these two add up to 180. That means those two lines are parallel. Okay. All right, last but not least, take a look at the information that they gave you. It says, what given information can it be determined that M and L are parallel? Yes or no? If yes, state the theorem. So if I look at these two, the two angles that I have congruent are this one and this one. If I look, these are what we call, and we haven't talked about these yet, these are same side of the transversal, but in this case, they're exterior. Okay? Well, those angles must be supplementary. And it doesn't say anything about them being supplementary. So this one's a tricky one because we haven't seen this one yet, but this would be a no. Okay, so the answer, are these lines parallel? The answer is no. Same side exterior angles, those must be supplementary. It's kind of like same side interior. Same side exterior must be supplementary as well. If I take a look at example B, this angle and this angle, those are alternate exterior angles. And those are congruent. We have two V's here. We have two V's. And in this case, we would say yes, those lines, M is parallel to N. Exclamation point. All right. Last but not least, as I take a look, I've got an exterior angle here. I've got an interior angle here. I could say with using vertical angles that these two are equal, but that still doesn't give me enough information. Okay. So whether it's same side interior or exterior, same side makes a C, or these are exterior, those are not supplementary. They're equal, but it doesn't say anything about being supplementary. So we would say no, those are not parallel. Ladies and gentlemen, that is it for today. I'll be back tomorrow to take questions. There's my math lab assignment related to this, so good luck. If you need whiteboards or anything, go ahead and grab some of those and get to work. Have a great day.